Basic arithmetic number 8, indices or powers. A power, or index, of a number shows how many times a number is multiplied by itself. An elementary example of this would be 2 to the power of 3, which equals 2 times 2 times 2. So 2 to the power of 3 means that 2 multiplies itself 3 times, and if we evaluate that, we get 8. Important things to be aware of with indices is that we have two elements that we'll be referring to. The large number at the bottom is called the base. The small number, which is called a superscript, is called the index or power. We need to be aware of these two elements as we work through the index laws. The first index law states that if I have two numbers with the same base but different powers multiplying each other, then I can take that same base and just add the two powers together. So an example of that would be x to the power of 3 times x to the power of 2 would be x to the power of 3 plus 2, and that would be x to the power of 5. Okay, the second law states that if I have two numbers with the same base, but one is being divided by the other, and the two indices are different, then we can subtract the indices. So we would have a to the power of m minus n. An example in this case might be x to the power of 5 divided by x to the power of 2, which would give us x to the power of 5 minus 2, and that's equal to x to the power of 3, or x cubed. The third law states that if I have a number raised to a power, and then that's all raised to a power again, then that's the same as having a to the power of m, and we multiply the indices this time, a to the power of m times n. So an example in this case might be a to the power of 3 all to the power of 2. That would be a to the power of 3 times 2, which will equal a to the power of 6. The fourth law states that if we have two elements inside a set of brackets and they are all raised to a power, then both of those elements inside the brackets are raised to that power individually. So an example of this would be 2x cubed. So we raise 2 to the power of 3, and we would have x to the power of 3. And if we evaluate 2 to the power of 3, we'll find that that's 8x cubed. The fifth index law states something very similar to the fourth index law, but we're dealing with fractions now. So if I have two elements inside the set of brackets raised to a power, still each element inside that set of brackets will be raised to the power. So we'll have a to the power of n over b to the power of n. So our example this time might be x over 3, and that's all squared. And when we expand the brackets, we'll have x squared over 3 squared. And if we evaluate the 3 squared, we'll end up having x squared over 9. The sixth law states something quite similar to the fifth law. However, we have a negative indice. So if I have a over b to the power of minus n, then to make that a positive power, we can simply invert the fraction that was within the brackets. So our example this time could be 2 over x to the power of minus 4. That would equal x over 2 to the power of positive 4. And then if we expand the brackets, we'll have x to the power of 4 all over 2 to the power of 4. And then you could evaluate that 2 to the power of 4 and find out that it'll be x to the power of 4 over 16. The seventh law states that any number raised to the power of 0 will equal 1. Some examples would be 2 to the power of 0 is equal to 1. Some other examples might be 1000 to the power of 0 is equal to 1. Or 2x squared to the power of 0 is equal to 1. And what many students find quite disconcerting is that 0 to the power of 0 is equal to 1. The 8th law is the negative index law. If I have a to the power of minus m, that's equal to 1 over a to the power of m. An example might be, if I have x to the power of minus 3, that's equal to 1 over x to the power of 3. The 9th law is the use of fractional indices. That says that if I have some element that's raised to the power of 1 over n, then that's equal to the nth root of a. Our example for this one would be x to the power of 1/3. That's equal to the cube root of x. We could do another example. X to the power of 1/2 is actually equal to the square root of x. Now we would normally just write a square root without putting a 2 inside the little tick of the square root sign, but actually that little 2 is always implied. It's just that we normally only write it like this, without the 2 included. The 10th law is a combination of the 8th and 9th laws of indices. So if I have a to the power of minus 1 on n, then that will give me, if we think about the 8th law using negative indices, that will give me 1 over a to the power of 1 on n, and then using the 9th law, that would give me 1 over the nth root of a. So our example for this one could be x to the power of minus 1 on 3. That would equal 1 over x to the power of 1 on 3, and that would equal 1 over the cube root of x. And our last law is another application of the fractional index law. If I have a to the power of m over n, then that's equal to the nth root of a to the power of m, which is also equal to the nth root of a all to the power of m. I'll show you why it's important to be aware of both of these. In our example, we'll have 9 to the power of 3 on 2. So if we look at these two possibilities for how we can address this, one of these would be the square root of 9 cubed, or the other possibility is to find the square root of 9 and then cube that. They're the two different paths that we could take. Now if I go down this first path, we'll see that we've got the square root of 9 cubed, which is 729, and I just happen to know that that's 27. But most people wouldn't know off the top of their head that the square root of 729 is 27. However, if we follow this second path, most people do know that the square root of 9 is 3. So the square root of 9 is 3, and we need to cube that, so we have 3 cubed, and most people would also be aware that 3 cubed is 27. So this second path is perhaps a much easier path for doing that calculation. Now you need to get lots of practice in using the index laws.